Hey there. All right, so this is my walkthrough, run-through, click-by-click command of relative weights analysis. Now, the importance of relative weights analysis, or the purpose of relative weights analysis, is to better partition variance so that in a multiple regression model where we have a set of predictors that are correlated with each other, we want to know how much of that variance explained is exactly due to each specific predictor in and of itself, given that some of these predictors are correlated with each other. So it's a way of overcoming the problem of multicollinearity in regression. Well, all right, so let's get into the data set that we'll be using for this example. And this data set is looking at the predictors of different predictors of cognitive ability. So for example, we have vocab comprehension, reading comprehension, geometry analysis, etc. And we also have our demographic variables. Here we have our binary grouping variable, gender. But we also have some personality characteristics that we're taking a look at, such as like sociability, stress, worry, etc. And what we're looking at specifically is, so we have these cognitive ability and personality characteristics, and we want to see if are these types of predictors in fact predictive of vocational interest. So we also have different vocations. For example, we have artists, social worker, firemen, policemen, etc. So we're taking a look at whether or not some of these cognitive ability and personality tests, again, are predictive of vocational interest with respect to different careers that we choose. And to get this data set, I went to, or to call up this data set, I went to import data set. I clicked from not from CSV, but from Excel, and I browsed for my data set. My data set was saved to my desktop, so I located my data set there. Once I got it, I clicked open, and then once I clicked open, I went ahead and clicked import. Once I do that, it brings my data set into R, essentially, and here we see a preview of the data set. All right, so let's go ahead and get into the first bit of code here. Now, this first bit of code I'm going to go ahead and run is going to run our regression analysis, because this is not important. This is our masked errors that we're getting before, but anyway. This is our regression analysis, our regression output, because we want to know, well, okay, so to put it another way, there'd be no reason to run relative weights analysis if we don't have a significant set of predictors. If they're not significant of the outcome, there's no reason to run a relative weights analysis. We already know that the variance is not significantly explained by the predictors. So in order to make sure that the variance is, or that the model is significant in and of itself, we want to go ahead and run a regression model. Let's go ahead and walk through some of this code here. Line 7, we see that we have a library command which opens our read Excel package, which allows us to open and interact with Excel files. So it's activating the package for opening Excel. Then we see we have an attach command that tells R that we want to reference this data set with the rest of our code here and the variables that we select from it, so that we don't have to select each variable, call each variable each time from a specific data set, unless we have multiple data sets. But in this case, we're only working from one, so we should be good there. And then this bit of code here is looking at setting up our regression model. So in this case, we have LM command that is telling R that we want to run a linear regression, and then we want to take the variable I just randomly selected from my data set, the outcome variable social work, and the predictor variables age, reading comprehension, vocab comprehension, and sociability. And this is essentially telling us that we want to run our regression model And then this is telling R that we want to actually have a summary of that model in our output here. So here we see a summary of the model given our coefficients, etc. And then we also wanted to run, so the first output gives us our, looking through here, we have our model, but we also have our summary, which includes our point estimates. And these are, because this is an unstandardized regression model, we have our b values here, our regression coefficients, our b values, and to get our beta weights, we want to go ahead and standardize our model. And to standardize our model, we again do a similar set of functions in R, and we're still using the LM command, but this time we're scaling each of the we're scaling the outcome and each of the predictors. So we have LM command for our linear model, and we're scaling or centering our social work variables, age, gender, reading, and sociability variable. And then again, we're showing a model summary of our standardized model, and we're pushing that value into, then we have a push command, pushing this model into, this model into the variable multiple linear model standardized. And then we're reporting out, summarizing that model, which is displayed here. All right. That is our regression. So here we have, again, we have, these are our b values, and these would be our standardized b values, which makes them, these now are our beta values. Let's go ahead and look at the standardized model to see whether or not our model is in fact significant. Again, because we want to know that our predictors in our model are in fact predictive of our outcome variable. In this case is age, reading comprehension, vocabulary comprehension, and sociability, our sociability measure, are those predictors in fact predictive of the vocational interest of social work. In this case, we see that our p-value is less than 0.001, which is significant. We have our F statistic there, multiple R squared, which is 0.29 in this particular output here. All right. So we've basically ran our regression to test our overall model. Now we know that the predictors are significant, but we don't know which predictors are significant. And so RWA analysis, or not, yeah, relative weights analysis rather, helps us to better partition variance so that we know which predictors are in fact more predictive of the outcome than some of the others. So for example, age might not be as predictive of sociability as reading or vocab comprehension might be. But to take a look at that, we're going to run RWA analysis here. Boop, boop, boop. And this does take quite a bit of time, so I'm only going to run the first iteration. I'm going to go ahead and click run. Yep. Okay, so how did I get this RWA syntax? To get this syntax, I went to this website here, relativeimportance.davidson.edu. And there we go. Once here, I went ahead and clicked on multiple regression. I did kind of read through some of this because it does provide a nice review for some of the background information with respect to relative weights analysis. But okay, so this is the part where we're really interested in. We want to access our code, the syntax I referred to earlier. But I selected download the code, and then I got my file name from my R syntax when I imported my data set. Again, went to browse and located my data set. Once I located my data set, I clicked open, and it gave me my file name here. I copied and pasted this, to over here to our website here, formatted it for Mac with /user/Hudson Taylor, that's me, and the rest of our code there. There we see, yep. But okay, so getting into what we actually want to select here, the data set that I found was from an online database basically, but the data is in fact raw data. It's not a correlation matrix, so I went ahead and selected raw data, and I selected listwise detection, and then I inputted my particulars here with respect to my model. We see the criterion variable in this case is social work or vocational interest regarding social work, and these are my predictors. Again, age, reading, vocab, and sociability, and we have bootstrapping, number of bootstrap replications or iterations. Good. Our alpha value is 0.05. Check. And this, checking these two boxes here, basically, this first box here, what it does a comparison of each predictor. So it's a between predictor comparison of the relative weight significance. And then this box here does a check of all the predictors with respect to a grouping variable. In this case, I chose not age, but gender. And what this will do is allow us to determine if gender has a significant effect on, or significantly impacts the predictors. So, for example, does a predictor explain more variance for males than females, for example? We'll be able to determine that with this checkbox here. But ideally, I would hit submit, and I would want to run each iteration of this, which is n-1. So I have my 4 variables here, n-1. I would need to run 3 iterations, and by iterations, I mean including each of my predictors in this box here. So first it would be age, then reading, then vocab. I wouldn't have to run sociability because it would already be included with respect to each iteration. Again, n-1. In this case would be 3. I have my 3 iterations here, and I merged each of these iterations into the complete RWA analysis, and you see that here. But that is how I got my output from my RWA analysis. But because all the information with respect to my regression output and my relative weights analysis output, because it's so large, it wouldn't fit all into my it wouldn't all fit into my console. So I ran each one respectively and included it into this output document to refer to. All right, so now we're going to jump gears here. So now we have we see that we have our regression output. Again, our standardized and our unstandardized and standardized regression models, so that we have our B's and our beta weights. And we know again that the model is in fact significant. And because that model is significant, we went ahead and ran our relative weights analysis. Here we have our first iteration, including our first variable, which in this case I believe was age first. But before we can start talking about the variance explained by each predictor, we first have to check to make sure that each predictor is in fact significant. And to do that, we check our confidence intervals. In the confidence interval, you'll see here is it says if 0 is included, the weight is excuse me, misspoke. That's how you misreport analyses. But anyway, again, make sure I read it correctly this time. If 0 is not included, I repeat, not included, the weight is significant. So let's go through here, and we see we have each of our variables. But oops, okay, boop. All 3 predictors appear to not include all of the cognibility and personality variables. seem to be predictive as they do not include 0. But age, we see, has a negative lower bound and is relatively close to 0 on the upper bound. So we would argue that this is, in fact, including 0. And so age would not be a significant predictor of the outcome variable social work with respect to vocational interest. But anyway, so we know that each of the predictors, reading, vocab, and sociability, are in fact significant predictors in and of themselves. And now we can take a look at our rescaled relative weight, which partitions our variance. And so basically it, again, partitions variance so that we can separate how much of that variance is explained by each predictor. In this case, we see that the most variance is explained by our reading comprehension score, followed by our vocab score and our sociability score. So this would be saying that 31% of the variance is explained, 31% of the variance in social work vocational interest is explained by reading comprehension, our reading comprehension score. Interesting, it's not, I figured the sociability predictor would be a bit higher, but oh well. All right, so this would be our relative weights analysis. We can also take a look at our group comparison. Let's scroll down. Okay, here we go. Group comparison. Again, the group being gender, males and females. We take a look at each of our variables here, and we see, again, including 0. These are, again, significance or confidence intervals, and we're looking for significance such that if 0 is not included, the weights are significantly different between groups. These all include 0, which suggests that there is no impact of gender with respect to our predictors, which says that there's no difference between males and the predictive power of our predictors on our outcome, and there's no difference between or for females with respect to our outcome. All right, so this is our output, respective output for the analyses that we run here. Again, running our regression analyses, both unstandardized and standardized models, and then running all of our iterations with the rest of our code here. Here we see it there. And then we get this code from our handy-dandy relative importance website. And that is how we would run a regression, a multiple regression, and a relative weights analysis in R. Cheers.